Good morning, Geometry Honor students. So this one is for Unit 5, so Section 5.3, 5.5, 5.6 from the Big Idea textbook. So 3 different ways to prove triangles' congruence. So objective, apply the postulates side, 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 and angle, side, angle postulates. So as you can see that side, 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 so let's say that we do have 3 corresponding congruent segments, such as segment AB is congruent to segment DE, segment BC is congruent to segment EF, and segment AC is congruent to segment DF. Anytime they see anything like this happen, so this one, that means the triangles ABC is congruent to triangle DEF by using the postulate side, side, side. And then for side angle side, quite similar to the side, side, side one. So we got 2 pairs of corresponding congruent segments. So such as segment AB is congruent to segment A prime, B prime. And then segment BC is congruent to segment B prime, C prime. And as you can see that there's an angle right between those 2 corresponding segments. So angle B is congruent to angle B prime. So if you see anything like that happen, so this one, that means the triangles must be congruent by the postulates of side, angle, side. And then for angle, side, angle, so that means we got 2 pairs of corresponding congruent angle, such as angle x is corresponding to angle x prime, so see that they're both congruent. And then angle y is congruent to angle y prime. And then there's a segment right between those 2 pairs of corresponding congruent angle. So segment xy, segment xy, x prime, y prime. So if you see anything like that happen, angle, side, angle, so that means the triangles must be congruent. And now let's check it out some of the example. So like this one here, so given that angle 1 is congruent to angle 2, so segment AB is congruent to segment CB. So you want to show that the proof triangle ABE is congruent to triangle CBD. So basically what we need to do, we need to find out one of those postulates that we can apply so we can prove that the triangles, that they're both congruent. So start with the given, as always. So angle 1 is congruent to angle 2. So segment AB, so that one is congruent to segment CB. So given. Another thing that we notice here is that the angle 3, angle 4, so angle 3, angle 4, so those are considered the vertical angle. So definition of vertical angle. And for the last statement, so you want to just say that triangle ABE is congruent to triangle CBD. And the reason for this one is by using the postulates of angle, side, angle. As you can see that here, angle, side, angle, and then angle, side, angle. So here's another example. So it looks like this one is kind of like an isosceles triangle. So given that segment AB is congruent to segment AC, D is the midpoint of segment BC, and you want to prove that triangle ABD is congruent to triangle ACD. So for the given, so basically you just need to rewrite that all the given statement. Okay, so I'm not going to put it right there. And then for step 2, since we do know that D is the midpoint, so that means segment BD is congruent to segment CD, and this one is by the definition of midpoint. And then for step 3, so one thing that both triangle here that they share in common is that segment AD, so segment AD is congruent to segment AD. And this one, the reason for that, so since there's only one element, so this one is considered the reflexive property of equality. And then finally, you can state that triangle ABD is congruent to triangle ACD. And the reason for this one is considered side, side, side. Okay, let's keep going. So here's another one. So angle 1 is congruent to angle 6. BC is congruent to segment EC. And then you want to prove that triangle ABC is congruent to triangle DEC. Okay, so those 2 triangles. So one thing that we notice, angle 1 is congruent to angle 6. Okay, so let's set up the two column. Statements and reasons. So angle 1 is congruent to angle 6. So just write down all the given statement first. And the other thing that we notice here, angle 1 plus angle 2. So this one is considered 180 degree. You can say that's a linear pair or supplementary angle. Same thing happened with that angle 5 and angle 6, 180 degree. So this one, its definition of linear pair. And then the next statement, so you can just say that angle 2 is congruent to angle 5. So this one basically just using that the angle subtraction postulates. So once you subtract both sides by angle 1, over here angle 5. So subtractions properties of equality, you'll get those two angles congruent. Another thing that we notice, angle 3, angle 4, just like the previous example. So those two consider the vertical angle. So definition of vertical angle. And then keep going with that statements and reason. Okay. So therefore, since we do know that those two angles are congruent, the vertical angles are congruent, so this one, the triangle, can be proved by using angle side angle. So therefore, triangle ABC is congruent to triangle DEC. And the reason for that, it's considered angle side angle. Postulate. Okay, so one more example. So given that, this one's given, segment XZ is congruent to segment YZ. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. And then angle XZW. So this one is saying that's congruent to angle 1, okay? XZW is congruent to angle 1. And then YZW is congruent to angle 4. Okay, so this angle right here, they're congruent with that angle 1, angle 4. So you want to prove that triangle XZW. So XZW, this triangle here, it's congruent to triangle YZW. So what we need to do here, so it looks like there's some kind of transitive property we need to apply. Okay, but let's set up the two columns, statements and reason. Okay, in case I need more step here, so I put in the continuation with the two columns. So statements and reasons. So start out with the given as always. So XZ is congruent to segment YZ. Okay, so those two segments there. And one thing that we notice, so angle 1 it's congruent to angle 4, angle 2 is congruent to angle 3. So basically what this one is saying, that angle 1 plus angle 2, okay, so once you combine them, and that would be the exact same measurement as angle 3 combined with angle 4. Okay, so for the next statement, angle 1 plus angle 2, then that would be the same as the combination of angle 3 plus angle 4. And the reason for this one, you can say that it's considered, well, there are two things involved. Well, obviously it's an angle addition postulate, and also it's the angles of congruency. So let's put in angle addition postulate, and also angle congruency. because that once you combine them, so that means those two angles got to be the exact same measure as well. And then the next one that you want to stay here, so this one, since we do know that angle XZW, okay, so this one also we can just split the given. Angle YZW is the same as angle 4 given. So therefore, that means angle XZW would be the same as angle YZW. And the reason for that would be considered transitive properties of equality. And then finally, we notice that the triangle here, so this one can be proved by angle psi angle, angle psi angle. So for step 5, so triangle XZW is congruent to angle YZW. So we're using that once again, angle psi angle. Okay. So gotta be very careful with that things it's given. So sometimes all things given, and if you find out things that's not that kind of related to each other, so you want to find out the implication. Implication, just like the previous one, the midpoint, so that means the segment got to be equal to each other. And like this one here, angle 1, angle 2, angle 3, and 4, since we need to prove this large triangle here, they're congruent to each other, so we need to combine those two angles to prove that angle X is congruent to angle Y, or angle WXZ is congruent to angle WYZ. Okay, so thank you for watching the video today. So any questions, comments, so please put it up there in the YouTube bar there, the video bar for the comments. Okay, so, and I'll see you guys next time.